Hello, and welcome to our bonus discussion on Wednesday. I thought I would take some time and do a kind of a deeper dive on Databricks, in particular Databricks Community Edition. In particular, I thought I'd go through kind of the basic type of functionality that's involved, and the relevance. The reason that we care about it is a easy to use hosted implementation of Spark. And so the people that created, as I've mentioned before, the people that created Spark decided, gee, this is a really good idea. So let's go out and create something that lets us commercialize that and makes it easier to use. And that's where Databricks came to be. The basic idea here is that it is a cloud first offering. And what that means is that while it may be possible to get an on-premise implementation of Databricks, generally speaking, it's very difficult. Instead, you go to the three big vendors, so Amazon, Amazon AWS, Azure, or Google's cloud platform, and they have partnered with those three providers and offered Databricks inside of each. And in addition to that, this is the Community Edition, which is incidentally hosted on an AWS implementation. But regardless, it lets the users that are perhaps not as familiar with Databricks to have access to it. I'm having a few connectivity challenges, so bear with me. I'm switching amongst various networks to try to find something that is actually going to work. I'll go ahead and get started with Plan C right here, which is turning on a hotspot. So the back to the topic at hand, which is Databricks. So when you go to Databricks, after you've signed up, you'll land on a page that looks very much like this. The various elements here of interest that you care about is most of them are over here, and you've got this general region in the middle, which is kind of your landing zone, if you will. So the basic idea of that area is that you can come in here and do the common tasks that you want to do. So creating a notebook, a very common thing to do. But one of the things we'll do in the interest of time is go ahead and go and create a cluster. We can actually do it here. The reason I'm doing it now is because it takes a little bit for it to get up and running. The interesting part of the cluster we create is that it will have a single node in it. So it's a single node cluster. And basically what that means is the driver and worker nodes are all combined together. You can think of it as very much of being like a pseudo distributed cluster in the Hadoop world. So you give your cluster a name. I'm being very original, naming it after myself. You pick a runtime that is of interest to you. It is an option to create ones that are pre-configured for machine learning workloads. The GPU, though, doesn't really seem to be able to be turned on the free version, which I'd be a little surprised if it could. This may be something that's aspirational, but it's not quite there yet. But you can select a machine learning workload if you're so inclined, or you can just go with the typical configuration. This tells you the versions of Scala that is installed. That's 2.12, and the version of Spark 3.11 that's going to be installed. And you can see that that's basically the same here across all of these. The major differences there is going to be some of the foundational stuff that's been included inside of Databricks. So you're basically dealing with Spark 3.11. You do get a free 15 gigs of memory kind of cluster with this. And it basically, this is the key thing, is it's going to turn off after 2 hours of being idle. For more configuration options, you've got to pay. So that's one of the purposes of this environment, is to encourage you to upgrade to a subscription that you're paying somebody like GCP, AWS, or Azure for. Once you get everything the way you want it, you click on Create Cluster, and it's going to take it a while to do that. So while it's doing that, we'll go and take a look at some of these other parts of the system. You can see your most recent notebooks, but you've also got this concept of a workspace. The workspace here is, in this case, a single user. This is me whenever I created my account. But you also have, inside of a real environment, you have the potential of having shared stuff. So you can have notebooks that are shared amongst multiple users rather than having a single user own the notebook. So that hints at there's a security model at play here, right? That's a very simple one for this environment because it's basically just a single node, a single user sort of situation. But it's a very different thing whenever you're dealing with a a shared environment with lots of different people working. So you can control who can do what, who can create clusters, who can edit what notebooks, and so on. So as a simple example, I created this for discussion around various, how do you read data. In this case, I'm showing how to read data from R, or was trying to. We'll go back here to this one and take a look at load Titanic and R. I think I got that one up and working. And so here's a good example. And there's one key thing here to kind of go across is one, there's lots of different ways different languages that can be supported. So if I go back here and say create a notebook, I have the choice of creating 4 different languages of notebooks. It's important to note you can also, though, within a given notebook, switch to a different language by using a magic character, a sequence of characters at the beginning of a cell that says which one you want to do. For the purposes here, we'll say that we're going to create a Python, and this is going to be a, actually no, we'll create Scala because of this course. We're going to create a Scala notebook, and we'll call it Scala notebook, real original name, 1, just to create it and get us in and running. And so with that, it goes and it creates a notebook. You can note up here that it says what language it is, and you can actually switch to that. That's the default language. That's the language that if there's not something else inside of here that tells it what to do. So if you have something that says Python, this becomes a Python cell, and that's the magic string is %Python. So your very first instruction in the cell needs to be either the language you want to use, or if you're not doing it, it's going to default to the first one. And so this gets us into the realm of a notebook. You have the ability also to control, if you want markdown inside of your cell, you put the special character markdown, and if we do that and say hello world, it turns it into markdown, and you notice that it did a formatting change on us there. So we're still waiting on that notebook or that cluster to come up. In the interim, I'm going to pause for 1 second and go grab some code to show Scala in action. So bear with me. I'll be right back. Okay, and we're back. Sorry for the for you, a very brief pause. So what I went and did was one of the things that Databricks does provide is notebooks that you can use as starters, right? So they have this quick start of using Scala, and it is a Databricks notebook. And one of the things that you can do inside of Databricks is import in a notebook into an environment. And you do so by, whenever you've found a notebook that's of interest, you get the URL and you say copy and you're done. And then this part may be a little, again, not terribly intuitive. You have to go to Workplace, you go to the user, and you say that you want to import. And what that does, this is also how you would import a notebook if you had your own notebook that you wanted to import. In this case, what we want to do is import in their notebook, which tells us how to get started with Scala in Databricks. And what the first thing they start off with is the use of something called DB Utils, and that stands for Databricks Utilities. And Databricks Utilities is a kind of an important thing to kind of understand in the world there, because what this does is allow you to do certain kind of common functionalities. And in this case, what we're interested in is the file system. So the Databricks file system, and in particular, what this is going to do is list the contents of a certain directory. Again, I'm checking to see the status of my cluster. It's not quite up, although it looks like it just came up. So then if that's the case, we can start stepping through. What you do to run a cell is you have the multiple choices. You can hit Shift Enter, and that basically causes it to execute. Executing a cell that contains Markdown doesn't really do anything interesting. In this case, what we want to do is take a look at the contents of this directory, which is samples/docs. And so what that's doing is this is a location inside of the Databricks file system that's going to exist for everything. And when it's doing this, it's running this as essentially the same way it would run a Spark job. It's kicking it off to the main cluster, and it's doing some stuff. And it shows us what's inside of that location. So if we were to get rid of this /docs to see what's out there in samples, we should hopefully see more than just docs, right? So there's some data out here, some news groups, and so on. This is also showing us this display command, and what that's doing is lets us take and show the response of something, typically a Spark-ish sort of thing, in a pretty sort of format, right? So you can actually, this is a sortable grid, not that you can really tell it here, but it will sort. They happen to be the same, so it's sorting, but it's sorting, there we go, we can go to descending, so you can see it actually does sort. So it is a sortable grid, not in this case, but in some cases you can actually do visualizations here. So you can analyze your data doing things like a histogram and so on without having to use some external tool. The next thing is to talk about, this is an example of reading a file using the Spark context. So whenever you start getting into your deliverables, you'll start seeing the Spark context as the way you interact with stuff. In this case, spark.read and then .text file. This is also spark.read is how you potentially are reading things like a CSV. So in this case, and there's probably some help in here that can help us out as well. So we can go to the Help Center. While that's loading, I'll keep going. So in this case, what we've done there is a transformation. We basically said take it from the file system, load it in to what's essentially a data set of strings, right? And then the next step is we actually want to take an action. In this case, we're going to do a count. And that's going to tell us how many lines is in that file, that data set that we just loaded into memory. You can also do things like take the first, that's similar to the head with a 1. So it's basically reading the first line of that file and outputting it because it's the last thing. You could save that to a variable and then evaluate that variable, but this is basically evaluating, pulling that first line and essentially returning it as something that is being evaluated, and then what it's being returned as is a string that happens to be with that value. The next is to do some sort of a transformation. So in this case, we're looking for, we're basically filtering. That's the transformation. And what we're filtering is the lines that contain the word Spark in uppercase. And what that's doing is returning back a data set of type string, but it didn't really do much at that point because it told it what needs to happen, not necessarily something that's going to happen. It actually happens when you perform some action. So this is part of the lazy evaluation concept of Spark, is that whenever you are giving it a command, you're sometimes telling it what you want to happen, but it's not necessarily going to happen at that point. It'll happen at the point that you have some action that makes it essentially need to be realized. So there are 12 lines in those 65 lines of that data set that we've got into memory that contain the word Spark. Another way of making actions be realized is this collect. Collect is basically a way of essentially saying evaluate this and give me the resulting data frame. And then from that you can then do a take 5, which means give me the first 5 lines. And then for each one of those we're going to essentially do what's a function on top of that. So you're getting back a data set. You're saying I want to be able to use it. Give me 5 of the things, and on each one of them I want to print it. And so basically it's going to do a print line on each one of those lines, so you'll have hopefully 5 things get printed out, and which is what this is doing here. And you can see that it printed out 2, 3, 4, 5 things, right? So that it did indeed do what you would expect. So that's kind of a notebook to start with. So another thing you may want to do when we're in this realm of things is potentially get some data in here, right? Let me find a file. So I'm going into my folder on a different monitor and taking a look in the deliverables. Bear with me. I saw something, but I lost where I saw it at. Maybe it was deliverable 2. Livable 2 is Java. We don't want to do Java. So yeah, this will work. So okay, here's the cellular service areas file. We can basically, it's as easy as drag and drop to upload it into Databricks. And when we do that, it's basically uploading it into the environment. And so here we're presented with a choice. We can either create a table using a notebook or create a table using the UI. So what this is doing is taking that CSV and then allowing us to expose it as though it were a table inside of the Spark environment. So what I'm going to say is I want to do it as a notebook, and part of that is I want to go in here and do a little bit of work. I say I do want to infer the schema, and you'll note though this is Python. That's because it is the kind of the default language in a lot of ways for this kind of stuff. But basically, all I'm doing here is configuring it, and then this is the Spark read dot format, and it's the file type. In this case, the file type is CSV. The option is infer schema. That's what I'm saying here is true. The first row is a header, and the separator is the delimiter. In this case, it's a comma. And all that was a generated notebook based upon what it kind of thought about the CSV. It's not smart enough to really tell if it's a header or not, so we have to kind of tell it. Then the next thing is you want to pick a name for your table. And for fun, I'll just name it something I know is unique. And then we can run some SQL against it, and that's kind of showing that cross-language thing. I'm running this. I've got to attach it to the cluster that we created a moment ago. And so it figured out, well, you've only got one, so let's go with that one. And it kicked off the job after it attached it. So what that's doing is reading this CSV into memory with this command here, and it's basically doing nothing more than displaying it. Right now we've just got a data frame that's loaded in. We don't actually have it's not into a table just yet. So the next step might be to do some exploration. Not too sure much of that's going to be real good, so we can try just a line, and then you can customize it. So plot options. So what is the keys? Maybe it's license E is the key. And maybe here we want to anyway, this is not great data for doing visualizations, but the key concept here is that in this same control you have the choice of either showing it in a tabular format or being able to do some analysis on it using simple controls there. The next step is to create a temporary view. It's basically a temp table that's going to exist essentially for the life of the run of the cluster. It'll go away when the cluster shuts down. And so in this case, it's created a temporary table, and we named that table this. So if I copy that and I come down here to this SQL, I can then query that same table using this name. This magic string here, %SQL, says that the cell is an SQL cell, so what's inside of here is SQL. So we're crossing language boundaries here and seeing the same things that we would before. If we want to create a permanent table, we have to give it a name, and then you have to comment this out, or uncomment this thing. So we may want to call it that same name. In this case, it's a permanent table, and that means that it's going to likely exist the next time you log back in the cluster. It outlives the life of the cluster. We'll go ahead and do that and create a table. Then your next step might be to read from that table using Spark and Scala, and I'm doing a quick search to make sure I don't forget how to do this. And I think I've got it here. Bear with me one moment. So while I'm thinking that through, you can also see now that we did create a table out here, and obviously I can't spell permanent, but that's the table that I just created, and you have the choice of looking at it, so I can see basically the shape of the thing, the the columns, their data types, and also a sample of the data. So basically is a way of kind of interacting with it in a simple way. Give me one moment. All right, so this is borrowing a code snippet, but I'll go back over to my Scala notebook. And so I'm borrowing from an example, obviously. And then I just got to remember what I called it. And I'm going to go ahead and split that into two different cells. And this is another sort of thing to get used to. Inside of Databricks, you do this to add cells to your table. Or if you also are in a cell and you do this, and then when I run it, it's going to add me another line. So what this is doing is displaying that table that I've just done using SparkDoc table as a way of accessing the table. And then you're basically then able to go through and do equivalent of a select statement on it. You also have the ability to do spark.sql, and additionally you can read it from as a data frame and various other ways. This is kind of just a simple way to kind of get started interacting with tables. So not getting into a ton of the details, but the basic idea here is to be able to interact with and access data that you've uploaded into a certain location. One of the other things, back to our concept of a DB utils, is there are other magic commands that you can issue so that you can actually see what data is where inside of your environment. I don't want to go into all the possible things that you can do inside of Databricks, because then it sounds like I'm selling it or something. But there are a lot. And you can also do things like create tables from here. We'd already talked about clusters. MLflow, not necessarily terribly relevant for what we're doing right here, although it is interesting. It's a way of basically having insight into what's going on, certainly with machine learning models, but it can be used in other things as well. Importing a library is how you do extensibility inside of things. So if inside of your Scala you need the equivalent of a pip install in Python, that's where you would do it, is you import libraries. And in that case, you have the case of in the case of Scala, you're going to be doing something like searching Maven for it based upon whatever it is you're wanting to install and the various packages that go with that. And so in this case, it's looking through the Spark packages. If there's some particular functionality you need, this is where you would go and load it. So if you want to deal with something like Vero or Redshift perhaps, or maybe you're dealing with Kafka, you're doing something with a Kafka queue, whatever things it is that you might be doing, that's how you do the extensibility. There's also Maven Central. I don't know if it'll let me be able to search that, probably not. But if you know a certain thing that you're wanting, that's how you would go find it. And if there's a particular, generally speaking, you're wanting to interact with some technology or data format, that's when this comes to play, is you're going to go out and potentially load this stuff in. So with that, I've kind of talked for a while about Databricks and shown kind of how to kind of get started anyway. I'll try to do a little more in-depth and better discussion of this potentially later on, depending upon interest. So let me know what's relevant to you, what's interesting to you, and I'll be glad to do my best to address your needs or concerns. If you want me to recircle back to deliverable 1, we can certainly talk about that again as well. Main thing here is to make sure we keep making progress. The clock is still ticking. One of the things also that you may have noticed as being in the student mode here, if I go into the student preview, and I don't even have to, whenever Google Chrome rolled out a recent update, they basically broke a bunch of our stuff. The countdown timer up here is not working. Various other things kind of disappeared. It's a known issue. People are trying to work through it. It's going to take a while. So bear with us. You can always go to it in something like Firefox. It doesn't seem to really be impacting core functionality too much, but there are some aesthetics that are involved. So try to keep those in mind. If you have any questions about anything I've talked about or anything in general in the course, let me know. That's what I'm here for. Stay safe otherwise, and I will speak with you next week.